Okay, question 3b, here we go. There are some results of the tests from question 3a. You've got time in minutes to wear away 1 centimetre of rubber. You have 6 different samples for both natural and vulcanized. They've given you the range from smallest to largest for both of those, and they've given you the mean average for both of those as well. Sam says that results show that there is a definite difference between the properties of the two types of rubber. Use ideas about range and mean to show that Sam is correct. So there is 2 marks for this question. Your first mark is for saying the mean of original rubber is outside the range of vulcanized rubber. So if you look at your mean of the natural rubber, 13, it's not in this range between 32 and 37. They've also said ORA, which means all reverse arguments. So you could have said that the mean of vulcanized rubber, 34, is outside the range for natural rubber, 11 to 15. 1 mark for either of those. And the second mark is for the ranges of the original and the vulcanized rubber not overlapping. So 11 to 15 does not overlap with 32 to 37. So because the 15 is lower than 32, they're not overlapping, so they are very different. So there's your 2 marks. You weren't allowed just to say that one range was higher than the other, or just to say that the means are different. You've got to compare the means and the ranges to get any marks at all for that question. Question B, part 2. Vulcanization has changed the properties of the rubber. Which 2 statements, when taken together, describe why the properties have changed? You have to put ticks in 2 of these boxes. So the options are: molecules are held together by weak forces, natural rubber has a higher density than vulcanized rubber, vulcanized rubber has longer chains of atoms than natural rubber, and sulfur links the rubber chains together by covalent bonds, or sulfur increases the strength of the covalent bonds in the rubber molecules. Okay, so the molecules in natural rubber are held together by weak forces. That makes a lot of sense. That's why the natural rubber would be worn down easily. So that is could well be true. Natural rubber has higher density than vulcanized rubber. Doesn't make any sense. If the natural rubber had a higher density, it would probably be harder wearing, so we're thinking that one is not true. Vulcanized rubber has longer chains of atoms than natural rubber. Well, we should be able to remember that vulcanization is adding these sulfur cross-links, so you're adding the links between the polymer chains, so that it does not make any difference to the length of the chain. Sulfur links the rubber chains together by covalent bonds. It sounds pretty sensible, and sulfur increases the strength of the covalent bonds between the rubber molecules. No, it doesn't. It doesn't increase the strength of any bonds. It adds extra bonds between the molecules. So it's not the bonds in the molecules, it's the bonds between them. Extra bonds have been put in. So we're looking at box 1 and box 4 will get you your 2 marks for that question. Question B, part 3. Cross-linking is one way in which the properties of a polymer can be changed. 2 other modifications that can be used to change the properties of a polymer. So this is just revision, stuff you have to learn. There are a number which you could have talked about. Chain length, remember longer chains, bigger forces between the molecules. Adding a plasticizer, and crystallinity. Crystallinity are the 3 options. Any 2 of those will get you 2 marks. You can't have adding covalent bonds. Length is not enough. Branching instead of crystallinity as an opposite would have also got you a mark as well. Thank you for listening to question 3. Do come back and have a listen to question 4.